Section 5.5, Inequalities in Triangles. So starting this section, we have this comparison property of inequality, which says if you have a value that is equal to, or that is the sum of two other values, as long as one of those two values that are being added together is greater than 0, then the sum has to be larger than the first value that is being added. So this comparison property of inequality is really the reason that if you lead it, that leads into the corollary to the triangle exterior angle sum theorem. Remember, the triangle exterior angle sum theorem told us that the measure of angle 1 in our diagram is equal to the measure of angle 2 plus the measure of angle 3. So both of these angles have to be positive values, so they're greater than 0. So this corollary actually allows us to make two conclusions. The first one is that the measure of angle 1 has to be greater than the measure of angle 2. And the second one is that the measure of angle 1 has to be greater than the measure of angle 3. So using this corollary, this comparison property of inequality, and other properties that we've looked at in the past, we need to explain why the measure of angle 2 is greater than the measure of angle 3 in our diagram here in number 3. Now, we can't just say the measure of angle 2 is greater than the measure of angle 3 right away, because the angle 2 is not an exterior angle of triangle TOP. But we can say that angle 1 is an exterior angle of triangle TOP, so we can make the conclusion that the measure of angle 1 is greater than the measure of angle 3 because of that corollary to the triangle exterior angle sum theorem that we looked at right above. Looking at the diagram, we would also have to notice that we have triangle TYP being an isosceles triangle, which allows us to say the measure of angle 1 is equal to the measure of angle 2 by the isosceles triangle theorem. So now, because the measure of angle 1 and the measure of angle 2 are the same, we can take the measure of angle 2 and replace the measure of angle 1 in our first statement with it by the transitive property. So these three steps would be how or why we would be able to say that the measure of angle 2 is greater than the measure of angle 3 in this diagram. In this section, we also have a couple of other theorems. The first one is dealing with sides of a triangle. As long as the sides, if two sides of the triangle are not congruent, the larger angle lies opposite the longer side. So this is comparing angles based on the sides that they are opposite from in that triangle. So in the triangle drawn here, if we know the length of AB is greater than the length of AC, that means the measure of angle C has to be greater than the measure of angle B. Angle C is opposite the longer of those two sides, so that means it is the larger of the two angles. So using this, we are able to take the sides of a triangle and use them to list the angles in order from smallest to largest. So the smallest angle, based on this theorem right above, is always opposite the shortest side of the triangle. So if AC is the shortest side of the triangle, that means angle B would be our smallest angle. If BC is the middle length side of the triangle, that means the angle opposite from there is the middle sized angle, so that's angle A. And then opposite the longest side is always the largest angle, so this angle C is the largest of those three angles. So typically very easily for people when you have the sides shown to you in a picture with the lengths. Not always as easy without using a picture. So here we have triangle XYZ. I'd give you the three side lengths of the triangle. Still the same job is to list the angles in order from smallest to largest, but now doing it without a picture. So the key to this is being able to understand what angle is opposite a given side, even though you don't have a picture. So if you think about a side length, or the name of a side rather, The name of that side has 2 of the 3 points of that triangle on it, which means the third point that's not used is the opposite vertex or the opposite angle. So if we need smallest to largest, the smallest angle is opposite the shortest side. So if the length of XY is 12, and that's the shortest side out of the 3, the angle opposite from side XY would be angle Z. That would therefore be the the smallest angle. Side YZ is the middle length, and opposite of that would have to be angle X, so that's your middle sized angle. And then if side ZX is the longest, opposite of that would be angle Y, and angle Y would have to be our largest angle. We have another theorem that does the comparison the opposite way. If we have 2 angles of a triangle that are not congruent, the longer side of the triangle lies opposite the larger angle. So in the diagram for this one, we know the measure of angle A is greater than the measure of angle B, which means the side opposite angle A is longer than the side opposite angle B. So we'd be able to say that the length of BC is greater than the length of AC. So similar to the last problems we had, we now have to list sides in order from shortest to longest instead of the angles that we had before. So here in triangle TUV, you're given 2 of the 3 angles. In order to show which side is the shortest, the middle, and the longest, we have to know all 3 of our angles so that we can compare all of them. So we have to find the measure of that missing angle T, which we know that angles of a triangle add up to 180. So if we just do some subtraction, we can find the measure of angle T is 60 degrees. So then shortest side would be opposite smallest angle. Smallest angle is angle U, which would make our shortest side segment TV. The middle sized angle is angle T at 60 degrees. Opposite of that is segment UV, so that is the middle length side. And then we have angle V as our largest angle. Opposite of that, segment UT would have to be our longest side. Now in 9, we want to do the same thing as we just did in 8. Given the 3 angle measures, we need to make sure we write our sides of our triangle in order, shortest to longest. Again, without using a picture. Same idea as we had with naming the smallest angle to the largest angle. This time though, if we just have the angle, the 2 points not listed in the name of that angle are the 2 points that are the endpoints of the opposite side. So if the measure of angle X is the smallest out of the 3, that means segment YZ has to be the side opposite from that, and therefore it is the shortest side. Opposite of the middle sized angle Y would be segment XZ, and opposite the largest angle Z would be segment YZ. So here are your sides in order, shortest to longest. Now I'd like you to use what we just talked about and answer this question. Which segment in this diagram is the shortest? So most people understand that you have to first find the measures of the missing angles, and you can do that using what we know about triangles. We know that the measure of angle C would end up needing to be 38 degrees. And we know that the measure of angle ADB ends up being 36 degrees. So most people will look at this and they'll look at all the different angle measures that they have, and they'll end up saying that segment DB is the shortest segment because it's opposite from 30 degrees, and 30 degrees is the smallest angle that they see in the entire diagram. The issue with that is you're not just dealing with triangles then. The actual answer is segment CD. Here's how you have to go about figuring this out. The first thing you have to do is you have to look at each individual triangle. So we have the triangle on the left, which is triangle CDB. We have the triangle right on the right, which is triangle ADB. In each of those triangles, you need to figure out which is the shortest side. So in triangle CDB, which side is the shortest? That would be segment CD. What's the shortest side in triangle ADB? Segment BD is the shortest side in triangle ADB. Now, looking at those two sides, CD and BD, we have to be able to notice that those are both in triangle CDB. So now we can ignore the triangle on the right and just focus on triangle CDB. So now we're really just comparing two of those three sides. We've narrowed it down to either being CD or BD. Within triangle CDB, DB is opposite of a 38-degree angle. CD is opposite of a 32-degree angle, which therefore means that segment CD has to be the shortest segment in that triangle and therefore in the entire diagram. These have given people trouble in the past, so make sure you understand the thought process that goes into figuring this out. Our final theorem for this section is the triangle inequality theorem, which says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So for example, if I take the length of side xy and the length of side yz, that has to be greater than the length of xz. Now, since there are three different combinations here, you would end up having three inequalities that you would be able to write for this theorem. So the first thing this theorem is used for is to actually determine whether or not you can create a triangle given certain lengths. So if I give you lengths of 3 feet, 7 feet, and 8 feet, how would you be able to tell if you can make a triangle out of that? You'd have to show that all of the inequalities listed here in number 11, where we have the triangle inequality theorem, would end up being true, plugging those in. Now that can be a lot of work, so if we just think about this for a second, we'd actually be a little more efficient. If I take 3 and I add 8 to it, that's obviously going to be larger than 7 because 8's already bigger than 7 by itself. If I take 7 and I add 8 to it, that's obviously going to be bigger than 3 because those are both positive values, both bigger than 3 already. So the quickest, most efficient way of doing this is actually just to check one inequality, but you have to be very specific in how you do it. The inequality that you have to check is you have to take the two smaller sides, add them together, and check that they are larger than that longer side. So here I have 3 plus 7, checking that that's greater than 8. 3 plus 7 is 10, which is greater than 8. And because that is true, because that is a 10 is greater than 8, I can say that yes, those values would be able to be the lengths of the sides of a triangle. So now I want you to do B and C. Would you be able to create a triangle with B? Would you be able to create a triangle with the lengths given in C? With B, you'd have to check the inequality where you take 3 plus 6 and see if that's greater than 10. You get 9 is greater than 10. That's not true. So these cannot create a triangle. With C, you'd have to check that 2 plus 7 is greater than 9. 9 is not greater than 9. It's equal to. So those three lengths also cannot create a triangle. Finally, the last thing you'll have to do is if you're given two lengths of the sides of a triangle, you have to give the possible lengths for the third side. So here we have lengths of 8 centimeters and 10 centimeters. How you have to approach this is you have to consider the longer of those two given, the larger of those two given values could possibly be two different things. The first is that longer one, in this case 10, could be the longest side of the triangle, which would then make you have to go through and write the inequality where the two shorter sides would have to add together to be greater than that longest side. We don't know what that other side is, so we just allow it to be a variable, and we would solve. We'd figure out that that third side, in this case, if 10 is the longest, would have to be greater than 2. Doesn't mean it has to be 3. It could be a decimal somewhere between 2 and 3. The second possibility is that you have to think that 10 is not the longest side. It's one of the shortest two. So that means you'd have to take the 8 and the 10 and add those together and figure that that has to be larger than the third side, which would be your longest side. So 18 is greater than x. So we have x has to be greater than 2, but it needs to be less than 18. So between those two individual inequalities, we need to write this compound inequality to show the range of the values that that third side could actually be. Your answers in this, again, must be written as a compound inequality, just like the one that I have here for you. So using that, I'd like you to take a shot at the last one on your own. Here, if I consider the 12 to be the longest side, one of the other two shorter sides would have to then be greater than 9. If I consider 3 and 12 to be the two shorter sides, that means the longest side would have to be smaller than 15. So combining those two to my compound inequality, we need to have 9 is less than x, which is less than 15 as our answer.